primarily focused in around faster and accurate performance test scripting.
All right, so just a few housekeeping items here before we officially get started. We will be recording today's webinar, so don't worry if you have to miss part of it, or if you have a friend who missed it. We will be emailing the link to the recording a few days after the webinar. And just to get started here, we want to give a little bit of background about who SmartBear is as a whole, and how not only how we got started in the load testing industry, but some of the other software products that we cover in our portfolio. So just a background on who we are as a company. We were founded in 2009. We have 11 offices around the world with 6.5 million users across that span, over 20 million customers. Here you can see just some of the depth that we bring with our SmartBear portfolio, having tools in every stage of the software development lifecycle. And we also integrate with some of the most popular third-party tools in the deployment stage. So for today's webinar, we have our product manager, Keshav. My name is Elliot Landon. Keshav will be talking through, the best practices, introducing the aspects of AI when it comes to performance and load testing. And then I'll give a brief demo on how we can implement this with our tool, Load Ninja.
And we can, before we get started, I just want to mention a quick promotion. So I know everyone's taking time out of their busy schedules to listen to us talk about performance testing and using AI. So as a token of gratitude for your time, right now in this webinar, if you can take towards the end of the webinar, you feel free to sign up in the link over here, loadninja.com/free trial. And if you run a load test in your trial, we will be mailing you a free SmartBear t-shirt, absolutely free. So again, this is just a token of gratitude for Iron, and we really appreciate you taking your time to actually try out Load Ninja. So let's dive right into it. Our agenda for today is to first discuss on a high level the state of software development and testing as a whole. We'll then narrow into understanding how AI has matured in the software testing space and where we see AI progressing within that siloed space. From there, we'll dive a little deeper and understand how you can actually use AI in performance testing, followed by a quick demo to showcase some of the things that we just mentioned in the slides. So let's get started. Let's talk about the state of software development and testing. So SmartBear last year, actually it's something which we do on a regular basis, is conduct a state of testing survey, which goes out to to thousands of testers and developers to understand, how their software development as a whole has matured over time. What we see is essentially software teams are releasing faster than ever, right? So we're seeing more and more people adopt agile principles. And we see on a given time, for example, more people are actually moving from monthly and quarterly releases to weekly releases over time. Right? And this is something which we see consistently since we've started taking this survey, and which is, teams moving faster and releasing more quickly. And this is, of course, primarily happening because of the needs of the consumers of these web applications, right? As the consumers of web applications, you and me can both relate. We want things much faster. We want to make sure that we are getting new updates on our Netflix as quickly as possible. We want to make sure that we're always getting the best features for all of our tools. If not, we move to another competitor because the switching costs are going lower and lower. And as such, product teams and engineering teams are forced to release faster. As a byproduct of this, QA teams have to now evolve and adapt in order to meet the growing demands of the end users, and also more importantly, to meet the growing speed of software development as a whole. Which is where it's becoming more interesting to see how the business priority of performance testing is also increasing. Then this is seen because primarily there's dollar values or revenue associated with having good performance, and vice versa, loss of revenue when it comes to bad performance. These are some interesting statistics. So for example, we see that 40% of people abandon a website when it takes more than 3 seconds to load. Even a second delay in page response can result in a 7% reduction in conversion. So you can imagine the impact it may have on your revenue. We also see, for example, 2-second delay in sales transactions results in abandonment rates up to 87%. All of these things are impacted, are essentially a function of poor performance. And hence, there's a big need in today's market, in today's software development teams, to make sure that their application releases and their application in general performs as intended and performs and meets the criteria that their end users have come to expect. Right. So if you look at the typical tester's journey, you have different, we can segment this into a few phases, right? So there's the requirements and planning phase, where which is the phase where the tester essentially starts, right? This is even before you start scripting and writing your tests. It's essentially working with the product team, working with the UX team to understand essentially what are the different high-level requirements of what you're trying to test. What are the different user flows? What is the business need of whatever feature that they're working on? And what is the expected flow and usage of those functionalities? You then come into, once you understand this, you go in and actually design and create the test, uh, which is where you things like, for example, taking the end user transactions that you've thought through in your requirements and planning phase and putting that into maybe code in a script, and making sure that it actually works and plays back successfully. Then, of course, you configure your test and then you run the test. And this is where you essentially run the test and analyze the test, work with different stakeholders to look through, for example, what you've uncovered during this test, and identify certain key areas and work with, say, engineering to debug them as well if needed. And finally, as you do the maintenance, you've done all of this stuff, there's also the requirement for maintaining these tests, right? Because you don't want to keep reinventing the wheel constantly as your application evolves. So there's some effort involved in order to operationally make sure that the tests that you create are maintained over time as well.
So this is the typical tester's journey, but we want to make sure that we hear your voice during this webinar as well. So we just launched a poll. If you could answer it, just so we have a better understanding about your day-to-day testing practices, if you're responsible for both performance testing and functional testing, it really helps us understand, how you guys are currently testing and, and how it is in regards to the typical tester's journey. All right, so we'll give it about 5 more seconds. Thank you everyone for participating. We really appreciate this.
So when we covered the tester's journey, now if you want to take magnify that view a little bit and look through like the different phases within that high level tester's journey, you have the test creation and the test running and analysis section part, which where people may tend to spend most of their time. And within this time, if you'll notice the test creation and in the test creation, test design phase, you have the creation of the test script, and then you have to make sure that the script actually plays back, right? So you're identifying objects as part of your script, and then you want to make sure you can automate that in the playback. Then you have the running of the running of the test, and when we specifically in the performance testing world, it's the configuring of the load test and running the load and generating the load and so on. And then finally, you get the results, you analyze the results and identify any performance issues and try to debug it. Typically, the creation aspect and the analysis aspect is something which requires human effort, right? There is an element of manual effort involved. The phase in between, you can essentially automate. Where we want to talk about is essentially specifically if in this webinar we can talk about how AI can actually help uh, decrease the effort that it would take for you to, for example, go through the manual parts of the tester's journey, which brings us to AI in software testing. So what really is artificial intelligence? I put this slide down so that we all have a common verbiage and language of understanding what this is, because there's a lot of different descriptions and definitions of what AI is. For the sake of this specific webinar, and our understanding of AI is essentially a system which has self-learning capabilities that is able to supplement human cognition and activities by understanding the environment that they're functioning in and perform basic human tasks and help the human itself themselves get the outcome that they want in the quickest way possible. So key items over here is the self-learning aspect to it, right? Where it's like where the algorithm actually learns, looks at the specific environment that it's functioning in, and improves itself based on how the environment evolves over time as well. And finally, and primarily to improve on the outcome that the human is doing. So, many people think that AI is something where it has to be self-learning, but fully self-learning, can talk to us, can essentially um, predict everything that could potentially happen in your system, but we're not there yet, right? AI, there's like little examples of AI that we see on a regular basis, right? Which is essentially a combination of machine learning that scans through your system and predictive analytics, which essentially, or predictive methodologies of scanning the system and potentially suggesting outcomes that based on what they've scanned based on historical data over time, right? For example, the Gmail aspect, right, where you can essentially Gmail scans through your email and also across hundreds of thousands of other emails and predicts what your potential outcome or response could be, and vice versa when you're actually talking to a bot that has an AI algorithm built in that is also learning by itself to communicate with real humans. And what we see over here is, the way the market evolves is, and the speed of releases is actually a function of how technology evolves as well to enable the faster delivery and releases of software applications. We've seen, when the open source market was booming, when open source became a huge component of software development as a whole and the software testing, software market as a whole, probably I would say mid 90s to like, probably 2010 was when it like really kicked off in full swing. That's when, people started talking a lot about test automation. How can we essentially start using test automation tools, and how can we um, automate our testing frameworks as a whole? Then we have, as microservices and the DevOps culture became big, we also had agile testing. How can you essentially start incorporate testing along with your development in order to make sure both of them happen parallelly and together and work instead of working in silos and instead of working without necessarily having the right communication. What we may see over time is, as the space of AI, ML, and robotics matures, we may also see a level of autonomous testing that is also going to be progressing and maturing, which would potentially allow us to enable releases that happen not in terms of hours or weeks, but even in minutes potentially. And so this is probably the long-term goal of where we want to be as an industry. But primarily for now, our focus is around agile testing and continuous testing, and using what we have right now in the AI and ML space and using that to drive us forward in the agile and continuous testing. So coming back to where AI can actually help in the tester's journey, right? So this is where, if you have the manual effort parts of it, this is where you can essentially, if you have the test creation part of it and the analysis part of it, that's where you can potentially use some elements of AI in order to assist you to reduce some of the manual effort, and as a byproduct of this, deliver test results faster. So AI can really mitigate common UI issues coming in the way of faster delivery, UI testing issues, right? So we have, for example, certain key industry improvements that have happened, and some forward-thinking tools have adopted the technologies that exist. There's, for example, the object recognition. So whether it's a programmer writing test software, an open source test software user, or even a commercial test automation framework, reading and interpreting the document object model is critical so that each object can be described and identified in an automated fashion. Right, so this is really fundamentally a part of your script and automation framework. How can you essentially identify the objects in the best way possible, based as your application evolves and as your developers start adding new functionality as well? Then there's, of course, the framework generation aspect of it. This is something which is very interesting. It's something which there's the technology exists, but it's probably not as mature as we would like it to be, which is essentially automatically scanning your application to recommend the best test framework as well. And then finally, of course, there's the risk profiling aspect to it, wherein you want to essentially see, for example, one second. Oops. where you want to see, for example, prioritizing certain tests and uh, prioritizing certain functions as a whole based on the business risk that it may require. This could be, for example, when there are certain frameworks that exist where you can, as a tester, feed in the business priority, and automatically the testing tool will look through all the different scripts that you have and show you and identify which are the ones that are at risk and which are some of the things that you want to essentially pay more attention to. So, right. Now let's dive right in and understand how you can essentially use these some of the concepts that I mentioned over here, which is AI, and use that to actually focus on real browser-based load testing, right? So, for the purpose of this discussion, we will be focusing on the object recognition aspect to it, right? This is one of the more mature aspects of the AI, and this is something which you can actually use to really accelerate your performance testing as a whole, especially in an agile testing environment. But to better elaborate on this, we need to understand first some of the challenges that typically performance testers as a whole experience, right? The first, and primarily this is around executing on the test coverage. The first aspect is scripting. Typically and traditionally in the performance testing world, the way you would record test scripts was by capturing all the interactions between the server and the client. This would include, for example, all the HTTPS traffic, all the chit chatter and the noise that goes through from the server and the client as your end users go through their transaction. So if you, for example, go through a simple login functionality, you would have to, as you're recording this, you would have to essentially record all the traffic under the hood as part of your script. Now, that's just one part of the overarching script creation process, because once you capture this, you need to essentially get it ready for playback. This would traditionally in the protocol testing world involve a process known as dynamic correlation programming, where you would have to identify all the different dynamic parts of that request response interaction between the server and the client, like, for example, sessions, cookies, anything else of that nature, and essentially programmatically create a variable and programmatically change them across all those different interactions. This process takes a lot of time. Right? Typically, when based on based on all based on our discussions with multiple people in the industry, like the hundreds of thousands, in fact, this we've come to it's approximately about 50 to 70% of a performance tester's time is spent just in the scripting aspect to it and getting it ready for playback. Add to it like more modern applications, which are like React, Angular applications, for example, which have a lot of client-side business logic, which don't talk to the server at all. The tester has to spend additional amount of time going through and actually script all those different transactions, because you're not recording all of them under the hood because there's no actual interaction with the server. So all of this additionally takes a lot of time. Now, if your releases, as you notice, is moving faster, so that means performance testers have to keep up with this growing speed of your agile teams as well. So this aspect to the scripting aspect is fundamentally one of the things that holds scripters back, holds testers back, and is one of the things which is why many companies have outsourced performance testing, or have, for example, a dedicated performance center of excellence where they do all the performance testing themselves. Then you have the actual configuring and running a load test. One of the challenges over here, apart from the load test server maintenance and the costs involved potentially in maintaining and running these load test servers, is also, for example, evolving your SLAs based on your application's performance. As you're having more and more features and capabilities put in, it's very important to understand how these capabilities affect your overall SLAs that you communicate to your stakeholders, both internal and external. Even like a 2% difference in SLAs could change, how your application behaves as a whole. So it's very important to identify and flexibly evolve your SLAs based on your application's performance and capabilities that you add in as your application matures over time as well. And that's important to reflect in different external and internal documentation as well, so that you can set the expectation right for different people. And finally, once you run the entire load test, once you've gone through the scripting aspect and actually configured your load test and generated the load, then there's the actual analysis of the performance results and debugging any potential performance issues that you uncover. This is where, for example, you as a tester have to spend a lot of time essentially translating the results that you obtain in a way that's more reflective of your end user experience. And what do I mean by that? Like traditionally, if you think of performance testing, specifically in the protocol testing world, you're, as I mentioned, you're capturing all the transactions, right, between all the interactions between the server and the client, all the requests and responses. The time it takes to send a response from the server is not equal to the time it takes to actually go through this transaction from a real end user perspective, right? So if say there's, for example, 5 different responses and then there's an index.html that loads up the page, the sum of all these responses is not equal to the overall time it takes for the end user to go through those transactions, right? Because there's additional things like DOM load time, the time to render the DOM, and also the waterfall the waterfall time it would take to actually to actually load up all those resources. Those are not necessarily reflected in the protocol-based traffic. So testers typically have to spend a lot of time to translate these results in a way that's more reflective of end user experience. And then they also have to make this actionable for the dev team. The dev team doesn't necessarily, your engineering team doesn't think in terms of request response in the HTTPS layer. They think in terms of DOM load time, DOM load time, and navigation times, and so on. So, those are the different challenges I mentioned. And with AI and using a combination of new technology in load testing, like for example, real browser-based load testing, you can actually overcome these challenges and actually reach the ideal of agile testing used in performance testing as well. So the challenge of scripting that I mentioned, you can essentially, solution for that is essentially creating scripts, not from the protocol layer, but from the browser's perspective. In this way, one, you're actually driving the browser to capture those transactions, and you're driving the browser to actually play back these different transactions without going through the protocol layer and without having to go through the process of dynamic correlation programming. If there's any client-side logic as well, there's no scripting involved to capture any of these interactions, like in a React app or an Angular app or any sort of like client-side AJAX calls that you have, because essentially the browser itself will capture these transactions and drive itself in order to, during the playback aspect to it. Now let's add the AI element to this, infuse this existing technology that we have in Load Ninja, for example, with AI, and you have a way in which the AI by itself will recommend what the best approach is, what the best way is to identify the specific item on the DOM layer, right? So you have, like, for example, the XPath, the screen coordinates, the CSS selector, the size of the object. There's multiple ways you can identify the objects just like a human. And so the AI will scan your application and pick what's the best way to actually get the object to get recognized and go for a successful and smooth playback. This itself will potentially save you anywhere from 50 to 70% of your time, because you're overcoming all the programming and dynamic correlation requirement, and also you're getting enabled with AI. The second aspect is actually configuring and running the load test, right? And this is where you can specifically over here, as the problem I mentioned on flexibly evolving the application's SLAs. This is where you can, using, say, for example, understanding how long it takes for the real browser or the real user to go through those transactions, you can understand, as your application evolves, what are the time it takes for that real user to go through those specific transactions. And that automatically informs how you define the SLAs of your load test itself, right? And Elliot will be showing you in the demo how you can actually achieve this practically as well using tools like Load Ninja. And finally, you have the overcoming the challenges of analyzing and debugging results. This is where you don't have to spend too long translating the results if you get the results as well automatically from the perspective of the end user. This is where real browser-based load testing becomes so useful, right? Instead of like having, for example, a load emulation agent to emulate the load, why don't you use a real browser to actually go ahead and generate the load? So tools like Load Ninja will actually help you spin up tens of thousands of real browsers, making sure that every VU that you see in your load test virtual user corresponds to a real browser. Which means automatically this is the most accurate and truest representation of load on your application. So the results you get back as well are reflective of this end user experience. And on top of that, you also get browser-based information, browser-based performance metrics, like, for example, DOM load time, the time to first byte, the SSL time, and additional metrics that will help you automatically send these results to your developers so that they can start debugging it without need of too much translation. So Load Ninja, as I've talked a little bit about, all the ways Load Ninja can actually help. So for people who have a question on what Load Ninja truly is, Load Ninja is a performance testing platform on the cloud to load test web applications using real browsers at scale. Right? So you have, for example, the ability to create scripts and instantly play them back without any coding, without any correlation whatsoever. Just record and play back. You can then take the script and spin up tens of thousands of real browsers, giving you the most accurate representation of load on your application. And you get the data that's coming back is real browser-based performance data. So this is not an emulator. Your end users are not using emulators, so you don't have to use emulators as well. So this is really a real browser-based information that you're getting. And finally, you can actually inspect and debug the errors and put performance issues all in real time as well. You can also automate this entire load testing effort, right? So I mentioned we have an AI capability. So you can essentially use the AI for the scripting aspect to it and really quickly generate scripts for your application. And then you can automate the entire load testing process using our public API, or we also have, for example, a Jenkins plugin that you can use to start doing incorporating load testing into your CI/CD world using real browsers at scale in Load Ninja. And then you can start to also, for example, integrate with tools like Zephyr, which is a test management solution on Jira, so that you can give your different stakeholders a more higher overview of the coverage that you have in your application as well. So this really is fundamentally, how you can essentially use a combination of real browser-based load testing and AI enhanced object recognition to really accelerate your scripting aspect. And to better showcase this, I'm going to be handing this off to my colleague Elliot over here, who will be essentially walking you through, for example, how you can actually go through the scripting element aspect to it, understand the SLAs that you have from your script, and then run a full-fledged load test as well. So Elliot, I'm going to hand it off to you.
All right, thanks so much, Keshav. And while I switch to share my screen, we again want to gain an understanding on what tools you currently have in place to perform load testing. So while I get my screen up and running, if you could please enter the poll that we just made public. It'll be in place for about 30 seconds while I get my screen up and running here. All right. Thank you again for your participation. And looks like we already have one Load Ninja customer out there. So thank you for being a customer and for joining today's webinar. So what we're seeing now is Load Ninja. This is SmartBear's own front-end load testing tool. We're looking at the dashboard right now. And one thing we'll notice right off the bat is that this is accessible through a URL. And that's because at the end of the day, Load Ninja is a SaaS-based tool. One reason we wanted to take this approach is because unlike other traditional load testing tools, it requires an installation on each tester's machine. And we really wanted to streamline the communication process, not only between other testers, but also between testers, the translation process that Keshav mentioned, from testers to developers. So in this aspect, we can navigate to our user settings, and we can add as many users as we want, add all of our testers on the same license platform, and all of our developers on the same license platform. Each one will be given his or her own separate username and password credentials. And in this way, if we have testers who want to work together to create more scripts on a shorter timeline, they don't have to save their scripts to a local machine, zip the folder up, and then email it to one another. All our artifacts here in Load Ninja are stored within a project folder. So if Keshav and I are working together, all he has to do to see the scripts I create is navigate to the same project folder. He can now make edits on any web tests or run any load test scenarios that I've created here from his account. One thing that we do want to mention, I'm sure a lot of you who do load testing right now do it in a development environment behind a firewall, we want to make sure that you can get up and running as quickly as possible within the tool. So the only download that would be required of you within LoadNinja is utilizing the endpoint. So based on the operating system and the bit architecture of the machine that you're using to access LoadNinja, you would download the associated endpoint. It's truly as simple as logging into the endpoint or the trial proxy using the exact same username and password credentials that you normally use to log into LoadNinja. You click connect, we establish a connection between LoadNinja's cloud servers, and now we are ready to test those internal applications. So I'm going to navigate to our project tab, and this really highlights how everything within LoadNinja is organized. When it comes down to it, within any load testing tool, there are three major components. The first being the recorded transactions, or the steps that we ultimately want to record and emulate in a load test. And those are going to be stored within the web test tab of a project folder. So at the end of the day, once we have all of those transactions in place, we want to set up some sort of configuration file where we'll designate how many concurrent virtual users we want to run in a load test, how long we want that load test to run. This will be done in the load test scenario file. And then once this is run or executed, either by a tester clicking run here within LoadNinja, or by integrating with our CI/CD tool or the pipelines, the results will be seen here in the test run tab.
One of the questions we've gotten, two questions already, and this is what I wanted to address, is how many instances of a real browser can be used on a single machine? And I think another person as well has the same question. So, questions, many people in the traditional world have been scared of using real browsers, primarily on the resource consumption. What LoadNinja has, essentially, we perfected a technology to scale up to tens of thousands of real browsers without any worry of resource consumption, because because of how our architecture is laid out. So we ephemerally spin up tens of thousands of real browsers to start hitting your application, and you're hitting your application servers and giving you the load. And we also give you, for example, information on what the load gen health is as well, like CPU usage and so on. So you can also see this as well as the application, as your test is running, to make sure the bottleneck is not the load test server.
Excellent. Okay. So one thing that I want to do just to get started is see, so everybody can see how easy it is to get up and started in recording a test within LoadNinja, is really just shift our focus today for the e-commerce application. So in a separate tab here, I have our Smart Store application where we can log in, log out, search for any particular product. And this really illustrates all the baseline knowledge required to record a test case within LoadNinja. In essence, we shift the focus from a developer's standpoint, or having to constantly communicate with the developer where session IDs are stored when we log in, having to go through the script and propagate that through the rest of the requests, and now translate that to just having a firm understanding with what use cases need to be modeled and recorded, and how end users are interacting with our web application. So in theory, we could take anybody off the streets here in Boston, and as long as they know how to interact with this e-commerce application that we're using today, they could, in theory, be the ones that are creating our transactions here on LoadNinja. So what we'll go through first is a typical login, logout transaction. I'll specify the URL that we're using to test, and I'll also specify the resolution that I wish to test under. This is extremely helpful because, as our applications may be responsive in nature, we want to add every last setting that could help configure end user behavior and model it as closely and accurately as possible. So I'll begin by clicking Start Recording. It'll take a second, but then we'll see this e-commerce application appear essentially in an embedded browser. And at the end of the day, this is a real web browser that we're recording on. Instead of recording the underlying HTTP traffic and then mandating that the tester be the one that translate all that traffic into separate pages, this is already done for us, and all the actions that are taking place on this page are also being translated into specific actions underneath each step on the left-hand side. So I'll sign in using my credentials. and then I'll immediately log out. So as Keshav mentioned before, at this point in typical load testing tools, this is where testers, face a huge challenge. They either have to have a really good baseline knowledge of how the application works or know how to code and take those session IDs, make them dynamic in nature, and then propagate it through the rest of the request, how to replicate those client-side JavaScript actions or any AJAX calls, or take time out of the developer's day and communicate back and forth when really we can streamline that process by allowing developers to focus on their work and abstract all of these dynamic nuances from the tester. In other words, we can take this recording just as it is and immediately play it back on a real web browser. So this greatly shortens the time it takes to create tests because we can instantly verify that this recording is ready to be used in a configuration file or a load test scenario right after the recording is finished. So we'll see Load Ninja iterate on the left-hand side through each of the pages that we navigate to, as well as perform each of the actions that took place on that page.
And the reason you're seeing it's a little slow is because Elliot was talking while recording. So that's why, for example, you'll notice that there's a little between the different actions, there's small delays. And that's, again, the reason. That's also a powerful thing of Load Ninja to recorders. We capture every single interaction. So, and you have full control of modifying these think times, these delays, and so on, anytime on the script level on the left as well if needed to reflect your end user behavior.
All right, so we'll click log out. And then finally, we see the results. Since all the actions pass on all of the pages that we recorded, we now understand that this recording that took all of about 2 minutes to record is now be ready to be configured into a load testing process.
Now, the other thing on the left you'll notice is the object recognition. So remember we spoke about AI a lot. So this is where truly the Load Ninja recorder is really infused with AI. So if you noticed on every single click element that we've had, any type of object recognition that went through, there was essentially what's happening under the hood is the Load Ninja AI is working in order to identify which is the best way in order to select an element. And we use a combination of multiple heuristics to identify an element. This could be the size of the object, the shape of the object, the CSS, the XPath, the optimized XPath, what is its position on the screen, right? So it's essentially just like how a human would identify the elements as well. So once you record the objects, during a playback, Load Ninja will go through and identify, the AI will identify the best way to identify the element and give you that recommendation as well. Of course, you can always override the AI if needed by checking that box over there. But the AI will essentially give you the best recommendation.
One thing that we also want to point out with the object identification, we will understand, obviously your application will evolve over time. The UI will change as developers make changes to the code. So we don't want you to have to reinvent the wheel every time and record an entirely new script just to accommodate a new UI layer. So in Load Ninja, we can make some changes through a couple of actions here. Let's say we still want to go through a login, logout button, but our UX team did some market research. They're finding out that the login button now needs to be featured prominently in the center of the screen. What we can do is the following. We can either, one, grab the CSS selector, the optimized XPath, and inspect the element in a separate tab and essentially just update the way Load Ninja is interacting with that element. So we would essentially just paste one of the object identification variables here on the left-hand side. And in this way, we don't have to re-record, and Load Ninja will still be able to interact with that login button as long as we update the path name. Alternatively, if any new UI pages are inserted on the front end, we can essentially record a new action and append a new event. Additionally, if a new page intermediary page comes in the picture. So if we click the login button and we're taken to a have you registered page, we could accommodate that change by adding a new page altogether. All of these options are at your disposal. We just want to make sure that you know how easy it is to accommodate these changes and not have to re-script every single time. All right, so what we'll do now is we want to look through the playback log. And as Keshav mentioned before, we can use the total amount of time spent in the page to really drive our SLAs by understanding how a baseline user is interacting with the web application. So by looking through this playback log, we can see not only how long it takes a user to interact with one particular page, but also each transaction or each event that took place on that page. So what we'll do here is understand on the login process, it took about 30 seconds to interact with all the elements on that page. We can now use this information to add an SLA validation within LoNinja. So we'll touch in this a little bit more in the next script, but at least for now, the SLA validation helps ensure that for any one of these pages, we'll call this our login SLA, the total amount of time spent on that page doesn't exceed the amount of time specified here. All right, so now with this in place, I'll save this script and we'll create one more. All right, so here you saw us sign in with one set of username and one set of password credentials. So it really wouldn't make a lot of sense from a time perspective if we mandated that you re-record for every permutation of username and password credentials. Analogously, what we'll record here is a user searching for one particular product within this e-commerce application. I haven't done an actual tally count, but I believe it's over 1,000 different products that we have here on our e-commerce application. So what we can do is leverage a data-driven testing aspect. In other words, LoNinja will be able to abstract the keyboard input that we're inputting into the search bar here. It will also be able to abstract the resulting page that shows as a result of the varying search queries that we initially input. And we'll be able to click on the resulting picture no matter what image or what product we initially search for. All right, so we'll notice here that each page gets named directly from the DOM level from the document.url element. So in order to accommodate this new data-driven workflow, every time I'm not going to be searching for a chronograph watch. So we can easily edit this step name to accommodate a more data-driven testing friendly workflow. So instead of searching for a chronograph watch every time, I'll be searching for a specific product. The resulting page we'll call the product page. And I just forgot to press enter in order for these changes to be made into effect. So now what we can do is upload a data bank in the CSV or TXT format. And from our local machine, upload this file. We have a smart source CSV file here. After telling LoNinja how the file is formatted, we'll see a quick preview of the items contained within that CSV file. And now we can use the column names and drive the input that was originally captured. So instead of searching for a chronograph watch every time, we'll replace it with an item from our Smart Storage CSV file and specifically from the InstaSearch text box column. Additionally, we can reduce the individual think times either on an individual event level or on a global web test level here. You'll also notice that in addition to modifying the think times on a global level, we can specify how Load Ninja should essentially choose data from that CSV file. If we want to go through in a random order, sequential and choose one product, one right after the other, or other in the order that it appears, or if we want to ensure that no two users search for the same product at any given time during the test run, we can utilize the unique setting here. Additionally, we can add different validations. From our poll earlier, it seems like a lot of you are tasked with the task of doing both functional testing and performance testing. So just to add and kind of implement that shift left mentality, we can add small functional checkpoints at the same time that we're doing performance testing. So if our team is very proficient in JavaScript, since we can access elements from the document object model level, we can implement those JavaScript validations here. As you saw earlier, we can add SLA validations and monitor the total amount of time spent on any one of these pages. But what we'll do here is add a text validation, and we can do this because we're reading the underlying HTML on a page. And I'm going to add this validation to purposely fail on the second page. Now, you might be asking yourself, why are you adding a validation to purposely fail? And this is just to show off some of the capabilities Load Ninja offers to the development team later on when we run a load test. And these capabilities and these resources will be available to our development team at the exact same time that our testing team are still analyzing the results. So we'll search for a chronograph watch. And we know because we're data driving this, anytime we're searching for anything other than a chronograph watch, this will fail. And we'll add the validation in place. So now that I have all of these recorded transactions, I'll save this file and we can set up that configuration file or the load test scenario now. So we'll include both the web tests that we've recorded today, and we can easily scale these concurrent virtual users. As Keshav mentioned, for each concurrent virtual user that you designate here in the load test scenario, we will spin up a real web browser with clear cache and clear cookies every time. So at the end of the day, it's not a proprietary WebSocket attached to a protocol-based recorder, and you're relying on that WebSocket's ability to emulate or to emulate those get and post responses to ultimately emulate a web browser. These are real web browsers that truly are aligned with how end users are interacting with the web application. We'll distribute the load accordingly amongst these two amongst these two scripts. We can also designate from different geographic regions where we want load being generated from. This is something we recently added to Load Ninja, but for right now, I'll keep it with the Northern Virginia region. We can run an iteration-based test as well as a duration-based test. And for the purpose of this demo, I'll run a quick 5-minute duration-based test with 1 minute of ramp-up time. Now, instead of having all virtual users come onto the platform at the exact same time, I'll add 5 evenly distributed ramp-up steps. So these are time intervals that designate every 12 seconds here, 3 additional virtual users will be added until we ramp up to that full 15 virtual user count that we previously designated. So when an error does appear, we have 2 options. We can either stop that iteration, Or we can allow our developers to come onto the platform and pause that error-prone virtual user in place for a specified amount of time here. Now we can click save and run load test. We can also integrate with your CI/CD tool of choice, so you can schedule these tests either to be done, on a time basis every week, or automatically trigger these tests, anytime new code gets pushed to our development environment, and or if our functional testing is now done and we want to kick off the performance of tests. This can all be done by integrating with our pipelines and leveraging Test Complete's native integration with Jenkins, or using the RESTful API that we have in place. So while this is spinning up, we want to make sure that, as you make changes to your application, you want to make sure that those changes made on the developer's end correspond with an improved performance factor, from a performance testing perspective. So once we have multiple test runs in a project folder under the test runs tab, we have now implemented a comparison tool. This allows you to ensure and compare across test runs and make sure that the latest test run that probably corresponds with one where changes have been made correlates with an improved performance factor. And let's say you can analyze the metrics as well as the errors that may have took place. And let's say only changes were made for one particular page. In essence, if the developers only made changes to the login, logout page or the sign-in set, we can focus on that step and only choose the metrics that we care about and we will want to use to analyze the comparison between these two test runs. All right, so we'll go back to our test run, and we should start seeing results on a live 5-second resolution. One thing that I really want to point out first is the virtual user inspector, because this is a feature that's pretty unique to Load Ninja. So here we have the capability to essentially look through Twoway Glass and understand how virtual users are interacting with our web application at scale. So if we had a physical product that we were manufacturing, we would get in a marketing studio and through Twoway Glass, observe how a sample group of customers are interacting with that with that physical product and take notes and make adjustments accordingly. Here, we're actually able to see how users interact with our web application at the scale designated. And this way ensure not only is our recordings playing back as intended, but also if there are any time degradations, we could experience from an end user perspective how they would feel here. So now with this understanding, we can go forth in the charts and statistics and focus our time and effort on those pages where the majority of time degradation is being experienced. On the virtual user debugger page, this is where we allow developers to get involved, and we can allow them to, for that amount of time that we've designated, to interact through the JavaScript terminal. And by accessing elements from the document object model level, just pull different characteristics, gain a quick understanding of what may be causing this bottleneck. And at the end of the day, the JavaScript terminal is the only element that will expire after the amount of time has elapsed. We can still download the underlying HTML corresponding with this error-prone virtual user. We can still go through the network traces, trace the critical path, and look in depth at the request, the response, a breakdown of the timing of this and each component of for this element, as well as immediately translate the data into this HTTP archive report format that developers use at the end of the day to debug information. So by taking the translation process out of the equation and providing this information to our development team, we not only streamline and allow more iterations to be made in getting a better version of our platform out to the public on the shortest possible timeline, we also take that element of human error out of the equation with any translation process. We can look at the charts and statistics associated with this test run and filter out, which scripts we want to be shown and focus on any particular steps to see which steps are contributing to any major time degradations. And at the end of the day, it's not only important to understand how users are interacting with your web application and the duration times, but also understand the navigation times, how your application is able to respond, and see if the network, how it's able to handle your web application. Because at the end of the day, the developers may have done everything on their side to the best of the ability, but the underlying reason are, we might be seeing such a, big time degradation is something in the network. In other words, if we see a very high DNS time, at the same time that we're seeing a sudden spike in our duration time, this leads us to understand that maybe it's our DNS server that's the major contributor to these time errors. So we can take a closer look in the statistics tab, look forth and gain a better understanding, and now act on this information, go to our DNS server with this empirical data, and now not only have all the analytics and insight necessary to address any problems within our internal team, but also to go forth and address any external variables that may be contributing to our web application's performance.
So that's so essentially in a nutshell, just to summarize what Elliot just showed you guys. We essentially showed you how you can essentially use the real browser enabled technology. Typically, some people may know this as True Client. Infuse that with AI and essentially allow you to record and playback scripts instantly without any hassle or worry about doing any programming or coding or dynamic correlation whatsoever. And the AI allows you to essentially better identify the objects by scanning your entire application and the objects recorded. From here, you can also, you see a playback log that shows you the entire transaction history that you had during a playback. And this can essentially inform you in a smart way what SLAs that you need to define for your specific load test as your application evolves as well with new features and capabilities. From here, you can configure a load test and run the load test. Remember, so on the big key differentiator over here, key differentiator is the fact that every single browser, every single view corresponds to a real browser, and this can scale up to tens of thousands of real browsers, right? So it's not a limitation where you have to unlike True Client, where you have to probably can run up to like 300 browsers and stop over there because of resource consumption. Over here, there's no such restriction or limitation whatsoever. So you can essentially do this all by yourself. And finally, the results that you get back as well is essentially the most accurate representation of load on your web application, because every single browser corresponds to, because the results you get back are nav timings information like DOM load time, SSL time, and so on. That's coming straight from the browser. So this really is in a nutshell what Load Ninja is. And for the most part, our entire promise that we deliver is the ability for you to essentially be able to record a script, take those scripts across tens of thousands of real browsers and run a load test without having to spend 80 hours going through and scripting and holding your entire team back.